Emstonette mantle radio, made in England. I wasn't planning to do a video on this, but given all the bodgy things I found, I thought it might be a bit of entertainment for everyone. Alright, so this was handed to me at the HRSA. Standard English mantle radio, you would think, but yeah, have a look at what's been done to it. Okay, now the first thing that stood out, now I should say this is a live chassis series heater set, 150 milliamp heater string with American valves. So I've got 35W4 rectifier, 12BE6 converter, 12AT6 detector and first audio, 12BA6 IF amplifier, and guess what the audio output valve was? Yeah, 6V6, which, as we all know, is a 6.3 volt heater, 450 milliamp valve. So the question is, what was meant to go in the output valve socket? As I'll explain later, I've worked it out to be a 35L6, 35 volt heater with 150 milliamp current consumption. So plugging a 6V6 into there, you wonder where all the extra voltage is going to go, and the fact that the 6V6 isn't going to heat up. And yes, we find that the 35W4 has an open circuit heater, as does the 12BA6. Okay, so it doesn't stop there. So having done that, have a look at the dial light. Now, that was originally an incandescent lamp on a socket here, but our would-be restorer thought that a panel of blue LEDs would be more appropriate. Now you'd think, oh, you know, all these LEDs are in the one unit, but they're not. What he's done, he's got these LED strips. They each have 3 LEDs and a resistor, but only one of them's connected. So only these 3 LEDs light up, and they're blue LEDs, so it's just god awfully ugly. It really is. But these 2 strips are just not connected to anything. It's incredible. But they've been mounted on what looks like a piece of building strap, and it's been riveted here and here to other pieces of strap which have been self-tapered into the front of the chassis, which we'll probably get a better view of it like that. But the next thing is how to power the LEDs. Well, these wires here run up to the LEDs, connected to pins 3 and 4 of the 12BE6, so that's across the heater. Now, anyone who knows about series heater circuits knows that the current is meant to be a specific value. But having connected the LEDs, which draw 20 milliamps, that means that the 12BE6 is going to be underheated, and there'll be a slight extra voltage across the rest of the valves. But the amusing thing is the person's obviously got no idea, because there's no rectifier diode for the LEDs. They're connected straight across AC through a 130 ohm service mount resistor, so there is nothing to protect the LEDs on the reverse part of the cycle. One just hopes that the reverse breakdown voltage is sufficient to protect them. Okay, so we come to the electrolytic filter condensers. These have been replaced. Note the 1 screw mount for this one. And looking over here, we see, if I can just focus in on it, this terminal here is less than a millimetre away from the chassis, so that's ready to provide a nice short circuit. Now notice this piece of figure 8 cable which has been cut and covered in heat shrink. Well, that's the original dial-light mounting bracket. So this is what originally ran up to the dial-light socket. So that's just been cut off. Yeah, the mains lead. Obviously, he didn't like the original figure 8 twin flex, so he's gone out of his way to fit this piece of heavy-duty 3-core flex. And why you want 3-core on a live chassis radio, I don't know. That's the earth wire that's been covered in heat shrink. But you can see he's gone to a lot of trouble to make up this aluminium bracket, and it's held in with 2 bolts and a rivet with a modern Heiko type cord grip grommet. So why that was done is anyone's guess. You can see the original cord entry grommet in the corner there. But have a look at how the neutral wire's been connected to the chassis. Instead of just soldering it to a convenient earth point, it's actually made up a solder lug out of a piece of tin can, drilled a hole and put a bolt in it. Probably looks like 3BA or something, 2BA maybe. So a lot of work just to avoid using the original twin flex mains lead. Oh yeah, and the dial pointer. Now this I found was actually mounted like that. So how can you see that from the front? Because we've got this diffusing panel here, so the light is meant to shine through and sort of evenly illuminate that, but our would-be restorer has made up this new dial pointer, piece of tin can soldered onto a cut-off nail, so you'd only get a very vague shadow of that. And I think finally, yeah, the dial string, well, he's used fishing line, but instead of one spring, which is the norm, he's added this extra spring here. Yeah, radio full of bodge. So we'll just have a quick look at the heater circuit and what's been done there. Now this is the circuit I've traced out as I've found the set. So looking at the LED connections, they're across the 12BE6, so no rectifier as such, just relying on the reverse breakdown voltage of the LEDs. 35W4 rectifier. Those of you familiar with this valve know that it's got a tapping for the dial lamp, but that's not used in this set. What should have been done by our restorer is not to cut the wires to the dial lamp shunt resistor, because with no dial lamp across there, extra voltage is being lost across this 147 ohm resistor, so the valve heaters are not going to get to their full temperature. So obviously the guy's got no idea about series heater circuits. There's a voltage selector which basically puts in an extra 100 ohm resistor. Now I don't know if that's the correct value. Someone soldered 100 ohm 5 watt resistor across a section of the dropper, so I don't know, but it's a likely looking value. So that's bridged out for 200 to 225 volt mains, and it's in circuit for 226 to 250 volts. Surprisingly, our restorer has got the mains polarity right. The neutral does go to chassis, as we saw previously, the blue wire. Now the question was, what was the missing output valve? Well, being octal and 150 milliamp heater, it's either going to be a 35L6 or a 50L6. So adding up the heater voltages, if we have a 35L6, the heater voltage there will be 107.8, and if it was a 50L6, it would be 122.8 volts there. Now the question is, how much voltage is going to be dropped across this 908 ohm resistor? Well, it's 136 volts at 150 milliamps. So just looking at our calculator here, nice Casio FX39 with a vacuum fluorescent display. So if we subtract our 136 volts from 240, that gives us 104 volts. So that better suits the 35L6 than the 50L6. Now, it would have actually been more efficient if the designers had used it at 50L6, because there would be a bit less voltage dropped across the heater resistor. Yeah, now the only other remaining question is the dial lamp. What that would be. Now, being an English radio, it could be some obscure voltage. A lot of English radios did use weird dial lamp voltages in their series heater sets, but just from experience, my guess is that a 6.3 volt 150 milliamp lamp will do there, maybe 250 milliamp. Now the reason for the shunt resistor is that you can't just put an incandescent lamp in series with a heater chain like this, because the cold resistance will be very low and it'll blow the dial lamp straight away when you switch the set on and they're all cold. So a shunt resistor is required. In some sets they have a thermistor, which is a better way to do it, because with a fixed shunt resistor you're always going to have to feed the dial lamp with a slightly lower voltage once the valves have warmed up and the current has dropped back down to the 150 milliamps. So that's the circuit. Yeah, next time you see this radio, we'll have a slightly different and more correct circuit, and I'll go through the restoration. Back again with the Emstonette. Now I've done a bit of work since you saw it last. So we've got the correct valves in it now, a 35L6 output, new 35W4 and a new 12BA6. As you can see, the two bodgy filter condensers have gone, and they're being replaced by a dual can type electrolytic, which is what was there to start with, and the dial has been fixed up. I've made a new dial pointer which is on the correct side of the diffuser plate, and that was made out of a piece of brass which I cut up and bent. I've added a fuse because there is a capacitor across the mains which could break down. I figured that we don't want to destroy the switch contacts should the radio be switched on with a shorted capacitor. So all good radios have a fuse, and as you can see, I've restored the original figure 8 twin flex mains cable. So new grommet, new cable, and underneath, what have we got? Yeah, you can see the new dual filter capacitor there. Changed the 0.01 audio coupler, of course, because that was reading 40 megs leakage. The 0.01 going to the 12AT6 grid I shall replace in due course. Now, as it stands, the radio does work, but there's a number of things I'm not happy about with it. So we'll have a look at the circuit diagram next. Before we get to the circuit, I'll just show you the dial lamp. I forgot to in the previous part. So there's a 6.3 volt 150 milliamp bulb there, and the other thing is the dial. I've restrung it. Funnily enough, I found the fishing line was actually better than dial cord, because instead of proper pulleys, they've just got these studs which are fixed, so there's a fair bit of friction, and I found that with thick dial cord there was just too much friction for the dial to work. And here is the attempted dial lamp replacement. So you can see here's one of the lead strips. They're just being stuck down with silicone, and as you can see, the terminals are not connected to anything. So that was that piece of bodge. Now to the circuit. As you can see, it's a fairly conventional superhead, using the American 150 milliamp series cedar valves, as I explained before. Few strange things. Now, the 12BE6 converter circuit is, yeah, kind of conventional in some ways not. It's got the radio's got 3 bands: shortwave, medium wave and long wave. So turning first to the aerial circuit, as is standard, the incoming RF is fed into the third grid of the 12BE6, and as we can see, the selector switch here brings into circuit the required primary. So when we're in shortwave, the RF current only flows through the shortwave primary and to earth. In medium wave, the shortwave primary is in series with the medium wave, but because it's such low inductance, it doesn't have any effect. And similarly with the secondaries, in shortwave, the bottom end of the secondary is earthed as normal. When we're on medium wave, the secondary of the medium wave coil is earthed. I should say that the medium wave coil is actually the loop aerial at the back of the receiver, and the shortwave coil is just a miniature iron cord coil on the chassis. Now, to get it to work on long wave, strange little circuit down here, which is a variable inductance and a capacitor across it, and my guess is that it's simply used to increase the inductance of the medium wave loop so that it will work down at long waves. So that's the primary. Oh, and the 0.001 isolating capacitor, essential with live chassis set, of course. And the next thing is the local oscillator, and this is when things get a bit strange. We've got the conventional single oscillator coil which is commonly used with a 12BE6, so it uses cathode feedback to oscillate. Now the 12BE6 doesn't have an oscillator anode as such. They're actually using this screen grid here, grid number 2, as the anode for the oscillator. So when we're in long wave, the 500 picofarad is shunted across the coil to bring the resonant frequency down to the long wave band. When we're in medium wave, it works as normal, with this being the pattern capacitor. This is the normal trimmer capacitor. And in long wave, when we're switched down here, the value of pattern capacitor is increased somewhat so that the oscillator runs at an even lower frequency. Now the peculiar thing is on shortwave, our oscillator coil gets feedback through the screen grid, so you can see that the B plus comes up here through the primary of the coil and then to the screen grid. So obviously they thought that the cathode feedback wouldn't be satisfactory for shortwave. Now one of the peculiar things is there's only one trimmer capacitor for the aerial circuit, and it's directly across the shortwave coil only. So when I get to the alignment of this set, it's going to be interesting to see just what effect this has, because being permanently across the coil, there's no way it can affect the medium or long wave section, so I don't know what they were thinking there. And similarly with the local oscillator, the trimmer capacitor only affects the long and medium wave. There's nothing for the short wave, so the tracking must be pretty awful. Okay, so beyond that, we've got normal double tuned IF amplifiers, standard 12BA6 IF, and conventional detector first audio circuit. So one of the 12AT6 diodes acts as the detector in the normal way, and the audio and AGC is developed across the 500k pot, and the AGC is filtered by the 2.2 meg and the 0.1 in the normal way, and that feeds the control grid of both the 12BA6 and the third grid of the 12BA6. So you'll notice that there is no bias resistor. The 12BA6 is biased only by what comes down the AGC line, which is a combination of noise, signal, and when there is neither of those, by contact bias. So believe it or not, a diode will provide a slight negative voltage, about 1 volt in this case, simply from the electron emission from the cathode. So there's always a minimum of about -1 volt on the grid there. The unusual thing with the first audio amplifier is the very high value of grid stopper resistor, 220k. So they're relying on the grid to cathode capacitance to act as a low pass filter with such a high value of stopper resistor, and I think they've done that because they haven't bothered to include an RF bypass capacitor at the plate, which is the normal practice. Again, the 12AT6 triode, being a high mu triode, is biased by contact bias. Again, the electron emission from the cathode causes the grid to go negative, and if you have a high value resistor of say 10-20 meg, it will allow enough voltage to be developed across the grid to sufficiently bias the valve. Now the plate load resistor is the usual 220k, and thence into the 35L6 by a 0.01, which is normal. 330 ohm cathode resistor, not bypassed, so there's a bit of feedback there, which is fine. 0.005 plate bypass, again that's standard, and the usual 2-section B plus filter. Now I had explained the power supply circuit briefly before, but the astute viewers will know or notice that the switch is now in the neutral side, and a lot of sets were built that way. It's an American practice, and it goes back to when sets used line cord resistors. But that's another topic I might explain another day. But I did trace out that this is how the set had been constructed. So again, the dropper resistor, the dial amp shunt resistor, and that's where the dial amp was. The mains voltage selector, shorting out this resistor here. Now you'll notice that I haven't included some of the component values on this circuit diagram because I don't know what they were originally. I can only go on what was in the set when I found it and what I have measured. So that's the circuit of the Emstonette, and next we'll talk about the problems with it. One of the undesirable things about the original circuit of this set is the power switch being on the neutral side. Problem with it is that the chassis is going to be live more times than it isn't. Now let's look at the possible scenarios. Okay, assuming we've got, as we should, live here and neutral here. Okay, so with the radio switched on, the chassis is neutral and safe to touch, and the rest of the circuit is at mains potential as you'd expect. So that's all good. Problem is, when we turn the set off, so switch is open circuit, we now have the chassis live all the time the set is switched off, because the live current flows through the heater string to chassis. So set is safe when it's switched on and dangerous when it's switched off, if you want to use that analogy. Okay, so if we reverse the mains polarity, is it going to be any better? Alright, let's assume this is neutral and this is live. Okay, when the set is switched off, neutral will go to the chassis through the heater string, so set is safe. But when we turn the switch on, the chassis becomes live. So either way you can't win. So I've modified it to something a bit safer, and as the would-be restorer did before, put the switch in the live line. So if we've got correct mains polarity, the chassis is always at neutral, regardless of when the set is switched on or off. And because we use polarized plugs and chances are the sockets are wired correctly, that's the safer of the options. As I mentioned before, fuse 250 milliamps to protect the set mainly against this capacitor shorting out, because that would bugger up the switch contacts. And another thing I found is that the dropper resistance it's too high. They've miscalculated it, so to get acceptable operation I've had to bridge out this 100 ohm resistor. I've got no idea if that was the original value, but that's what someone's tacked across the dropper. So it's on the 200 to 225 volt setting, and the filter capacitors, they're 40 microfarads, my dual can filter cap. That's all I had. Now 40 microfarads is the limit for the 35W4, so that's okay. And also we've got additional protection with this 200 ohm resistor, which is a lot higher than specified in the 35W4 data, so I don't see any problems with the 40 microfarads. Now to some of the design problems with this set. Firstly, as I mentioned just before, the heater resistor is too high. So with a mains voltage of 236, you can see we've got 11 volts across the 12AT6, 11.2 on the 12BE6, 11.5 on the 12BA6, 32.5 on the 35L6 and 33.3 on the 35W4. So they're all a little bit low, than I'd like. The dial lamp runs with 4 volts across it once the valves have warmed up. The scale illumination is adequate. So I'm going to probably have to shunt an extra resistor across there. Now why they chose 908 ohms I've got no idea. I don't know if they don't know Ohm's law or something, but I'll talk about that in a second. But the next thing is the 35L6 operating conditions. I'm not entirely happy with them. We've got 205 volts on the plate, so relative to cathode, which is at 14 volts, there's a little bit less than 200 volts, and that's okay. Now the 35L6 was designed specifically for AC/DC radios in the US, made for their 110 to 120 volt mains. So it was never envisaged to have such a high voltage on the plate, but nevertheless the data does allow for it. But the real problem is the screen voltage. Regardless of what the plate voltage is, the maximum screen voltage is 110, so that is being exceeded here, and it seems our would-be designers have thought that by over-biasing the valve that they've allowed one to get away with that. But having calculated the screen dissipation, I found it to be 0.52 of a watt, whereas the data indicates it should be 0.22, so it's being exceeded. The voltages have been exceeded, and I'm not happy about that, and I just wonder if that's part of the reason why the original 35L6 is not in the set. So I'm going to have to bring the screen voltage down by increasing this resistor, and that will also allow me to restore the correct 8 volts bias to the 35L6. Now, one set I've got is this STC, made in Australia. Now, STC also made Brimar valves, and Brimar happened to make the American valves in England, including the 35L6. So my assumption is that STC knows a good deal more about 35L6 operation on 240 volt mains than does the backyard company of Emstonette. So what STC have done is run the screen volt at 110 volts, which is correct, and the plate voltage is getting 190 volts. So I will modify the Emstonette to suit, and yeah, not have to worry about overloading the 35L6. Okay, this is the new screen voltage, 112, and the plate voltage is 203. The cathode voltage is about 6, and that's with a 4.7k filter resistor here. And now that this is 113 or whatever it was volts, this 12k resistor has been bridged out. So it seems to be working very well. The other thing, of course, is that the 330 ohm resistor is now its correct value of 180. Okay, for those of you who've wondered about using an AC-DC radio on DC, it does actually work quite well. I've been experimenting with the heater current. We've got a bit of noise here, don't know what's causing that. Just optimizing the heater dropper resistor, and the easiest way to do that is on DC, because DC amp meters tend to be a bit more accurate. So I'm using my BWD215 variable regulated power supply, which can supply up to 400 volts at 200 milliamps. So the radio with the 150 milliamp heater current is pulling 207 milliamps all up on DC mains. Okay, the Emstonette is just about ready to go back in the cabinet. We'll just have a quick look at what I've done. Dial lamp back in its proper place. Trimmer for the medium wave aerial coil. Really dumb design for them not to include that. New 12B06, new 35W4, new 35L6, new dual section electrolytic condenser. Tied it up around the dropper resistor. There's a 8.2k resistor across the 908 ohm section to get the correct resistance. 250 milliamp fuse for the main supply. Okay, so we'll just have a look underneath now. Under the chassis, filter resistor is now 4.7k to get the 35L6 screen voltage to what it should be, around 110. New dual section electrolytic, that's tidied up all of that. New 0.01 grid condenser for the 35L6. New 0.01 grid condenser for the 12AT6, and tied it up around there. Also shielded cable now up to the volume control. Dial lamp, of course, and new 0.1 AVC filter condenser there. This had a dry joint, the local oscillator grid coupler condenser, dry jointed on the tuning condenser that's being fixed. Changed the 470k grid resistor on the 35L6, that was high. The cathode resistor is now 180 ohms, which is more towards its correct value. New twin flex mains lead instead of that awful bodge. Okay, that's it, ready for the cabinet. Okay, notice how the dial lamp is bright when it first comes on. It'll dim down as it warms up. So, any second.
And we must run a campaign to attract medical students into the specialty of general practice.
Yeah, so think about advocates speaking of the existential erasure of transgender people.
The car, and it was like a wagon.
Yeah, so was it looked like a sedan? Come on, baby, ride.
Jay, I've never seen a plunge like it. Different people, different...
Your opinions. SEN 1170 AM, the home of sport.
His book about the Beatles, 1, 2...
They call it, that says sign the petition. You click on that.
It's fast. Together and one from Mockambora is Renati.
Is a really impressive, again, large SUV. So if you go to the website...
So there you have it, the Emstonette Mantel Radio.